Hey, we're here at gotomath.com looking at some calculus. Let's go down here. We're talking about implicit differentiation, and actually, make sure I've done all those. We are finding the equation to the tangent line. Boy, this looks like it's going to be a lovely one here. Alright, so let's write this down. We have 3x squared plus 4xy plus 5y squared is equal to 48, and we're at the point 2,2. We're at the point 2,2. So let's move over to the whiteboard. Let's write this down. So we have 3x squared plus 4xy plus 5y squared, and that's going to be equal to 48. And remember, we have the point 2,2 on the curve that the tangent line is going to pass through. So this is what we want to do. We want to find this right here, and the first thing we're going to do is find that, and that means that we got to find dy over dx of this equation right here by taking the derivative. Okay, so that'll be the first thing that we find. So let's go ahead and take the derivative of this. So we end up with 6x plus, now we'll have to use the product rule here, so 4x, the derivative of 4x is 4, and then we rewrite the second part, and then rewrite the first part, and the derivative of y is 1, but we're not going to write the 1, we're just going to write dy over dx. How's that? Plus, and then we have the derivative of this is 10y, and then we're going to write dy over dx, and the derivative of 48 is 0. Derivative of 48 is 0. Alright, well, what we're going to do instead of solving for dy over dx here, and then plugging our point in, what we're going to do is just go ahead and plug the 2 in all the way across. So let's do that. So we have 6 times 2. Believe it or not, you'll save time doing this. 2 is also y. So we have 2 for x there, and then we have dy over dx plus, and then we have 10 times 2, and that's also dy over dx, and we'll set all that to 0. Alright, so we have 12 plus 8 is 20, right? I believe that's right. So let's try to simplify it down a little bit. We have 8 dy over dx plus 20 dy over dx, and of course we can add those together, so this becomes 20 plus 28 dy over dx equals 0. And now we can just take the, we'll just write it right here. So we have dy solving for dy over dx now. We'll have bring the 20 over to the right hand side, becomes negative 20, and bring that 28 diagonally down, and now we can simplify this down to negative, what do we got? 2 goes into 20 10 times, 2 goes into, okay, I believe 2 is going to be our GCD here. 2 goes into 20 10 times, and then that's going to be 14. Oh, wait a minute, we're still going to be able to, 7 times 4, 7 times 4 is 28, isn't it? Okay. Sorry about that. Let's just rewrite this down here. Running out of room. 4 goes into 20 5 times, and 4 goes into 28 7 times. So that'll be our simplified version there of dy over dx. Does that make sense? 10, let's see, 14, and then 2 goes into 14 7 times. Yeah, okay. So dy over dx is negative 5/7. So let's go back over here. So we have y is equal to mx plus b, and remember we got the 0.22. So now that we found m, we have y is equal to negative 5/7 x plus b. Now we'll want to plug in our point. So we end up with 2 is equal to negative 5/7 times 2 plus b, and we'll just extend this over here. So let's go ahead and bring this over to the right hand side. So we have 2 plus 10/7, and of course that can reduce down to, we're going to get that one single fraction, 14 plus 10/7, and that is 24/7. Okay, 10/7, bring it to the other side. So finally that's our b right there, and we're going to write it right here. Y is equal to negative 5/7 x plus 24/7, and we are done. So y is equal to negative 5/7 x plus 24/7. Can we remember that? Can we remember that? We're going to hold our breath. Alright, agrees with the script. Y is equal to negative 5/7 over x plus 24/7, and there it is. So you'll want to come on by and practice, and you might chat with me there. Who knows? Alright, bye.